everyone. So we'll be presenting to you our EEE212 Microprocessors Project, which is focused on using electromyography signals to move a model hand and display the signals on an LCD screen. We use an EMC sensor to receive the signals. So we'll now present the first part of the project, which is moving the hand. When I contract my forearm muscles, the servo motors move the fingers of the hand, as you can see. Yeah.
And for the code part, we use the analog output from the sensor and directed it to the freedom board, then processed it to send a signal to the servo motors when we want. The principle behind it is when the sensor doesn't get any contraction from the muscle, it only sends a constant voltage, but when we detect a change in the voltage, we send this signal to the servo motors and get the hand to move as we want.
So here's how the sensor works. We have one electrode at the middle part of the muscle and one at the end. And we also have a ground voltage, which is at a bony part of the arm. And the sensor is basically a differential amplifier, and it detects the difference between the ground and the muscle part, and notices when a muscle contraction happens.
So that was the first part?
Yeah. Now it's time for the second part, but we must note that the first part and the second part, which are the servo and the LCD, do not work together because we initially tried to make them work together and their libraries were not compatible, so we decided to demonstrate them as separate implementations of the electrodes. Proposal, we promised to model model hand with the EMD signals coming from the sensor, and we mentioned that as an additional peripheral device, if we had enough time, we would also implement the LCD screen, which we ended up doing also, but in a separate manner, working not simultaneously but at different times with the sensor. We will now demonstrate the second portion of our project, which is displaying the signals coming from the EMC sensors on an LCD screen. So right now you're seeing the baseline voltage coming from the sensor, and when I contract my forearm muscle, we see a distortion in the signal caused by impulses sent from the nervous system to the muscle.
And that was also the idea behind the code that generated the servo motors, LCD as well. And I would say we worked around 30 to 40 hours in this project, and we mainly learned how to use a biomedical sensor and how to use other peripheral devices such as an LCD or a servo motor. And during the process, we burned our EMD sensor, and we had to use an ECG sensor, but it was working better than we expected and generated better results than the EMG sensor. And we worked together for the whole part of the process, the servo motors, the LCD, and the biomedical sensors. We worked together, yes.
Most of the time spent for this project was on troubleshooting and trying to solve hardware issues such as the EMG burning. But in the end, it ended up working just fine.